Hi friends, in today's video, we'll see how to simulate a three-phase sinusoidal PWM inverter. In order to begin with, we need to know what is a SPWM. The term SPWM stands for sinusoidal pulse width modulation. It is a technique of PWM used in inverters. An inverter generates an output of AC voltage from an input of DC with the help of switching circuits. And in this technique, we usually have two signals, that is a reference signal and a carrier signal. We need a sine wave, which is a reference signal at fundamental frequency. Frequency, which is required by the output voltage of the inverter, is called a fundamental frequency. So, sine wave is the reference signal, and sawtooth wave is the carrier wave, which is at high frequency. And when reference wave is compared with the carrier wave, and when the reference wave's magnitude is greater than the carrier wave, output will be high. If the reference wave is less than the carrier wave, output will be low. So this is the basic concept. Now, in order to begin with, first we have to open the Matlab window. And then in view, we have library browser where we can browse for all the blocks we need in this Matlab. So first, in order to begin with, we need a continuous block. To get that, search GUI and then add. In order to add to this Matlab window, on the left click on the mouse button, you have add block to model untitled. Since we have not saved this Matlab window, we can give this option and add the Kai button to the Matlab window. Similarly, all the below given blocks can be obtained from the library browser by searching the same keyword given here. For example, if we want to get a sine wave, go to library browser and just browse sine wave. And then if you proceed, you will get this block and then add this block to the corresponding Matlab window. Similarly, we have to obtain a sawtooth generator and then we have to compare sine wave and this sawtooth wave. So in this add block, we have to change the sign from positive and negative since we have to compare them. After changing the signs, we can make the connection. All the sawtooth waves have to be given to the negative part of the box. And then in order to compare with sine wave have to be given to the positive part of the add block. And then we have to do the comparison. So just go to the library browser and search for compare to 0. And then change the sign from less than or equal to greater than or equal to. And then make the connection. After that, the corresponding signals are given to the switches 1, 3, and 5, and the inverse of these signals are converted by using a logical NOT operator and then given to the 2, 4, 6 switches of the inverter. So first name the switches. This is S1. This is S2. Sorry, that is S4. Corresponding to 1, we have 4 in the inverters below part of the switch. And then we have S3. Bottom of the S3 has S6 switch. Then S5. And finally S2. Change the logical operator from AND to NOT. And then make the connection. After that, we can start with the inverter. For inverter, go to the library browser and search for MOSFET. And then using Control and R, you can rotate this block. And to change or to flip, we can left click on the mouse, and there you can see rotate and flip. And there you can see flip block name, flip block. And then you can click on the left to right. So your block has been flipped. Correspondingly, we need 6 switches, 3 on the top, 3 at bottom. All the D part of the switches are connected. S part of the switches are connected. And then we have 3-phase VI measurement. Search in browser as 3-phase VI measurement. You'll get this block. And then connect to B, C. Finally, we need a 3-phase load connected to A, B, and C. And then ground the load. Finally, in 3-phase VI measurement, we need not need the current measurement. So put the option no for that. And then demax the voltage. We have 3 outputs here. So change the outputs to 3. Finally, we need a scope to print the out. So scope and add to the model. We have 3 signals to be printed. So change the scope input by left click on the mouse and then change the number of input ports by going on to signals and ports option. Then click 3. Demax all the signals. And then in order to give from signal, from this go to corresponding go to signal, we have to give a from block. Give the label as S1, S3, and S5, S2, S4, and S6. Sorry, this is S4 and this is S6. Connect to DC source. And then finally, we have to give a 120-degree phase shift to the signals with frequency 50 Hertz. So 2 into pi into 50 is the frequency. And the phase for here, for this block it is 0. And for the next sine wave, frequency is 2 pi into 50, but phase is 2 into pi divided by 3. And for next sine block, frequency is 50 Hertz or 2 pi 50 radians per second. And the phase is either 2 pi minus 2 pi by 3 or 4 pi by 3. And then we can run it. Once our model has been finished, We can save this onto our computer as file and then click on the save as, give the name whatever you want, and then save it, and then click on the simulation and run. Now we can see the output voltage waveform of the inverter. Click on the scope, and then if you want to change the view or layout of this video, you can click on the view, go to the layout, and then you can choose whichever layout you want. So this is the output voltage waveform of the inverter with SPWM technique. That's all about the video. Thank you.